Hello, we are the group number 2129, made up of the student Irem Dundar and OmarP.P.Znakar along with the mentor Professor Janes. This is the index of the presentation that we will see during this video. As we can see, we have 6 sections. The first 3 will be discussed by me, OmarP.P.Znakar, and the other 3 by Zeynep. Next, we will see the introduction to the project. The aim of the project is to try to predict energy consumption. However, we will not only have to focus on this objective, but we will have to do it in the shortest possible time. To achieve this, we have to provide with a script that uses data log. To improve the script that we have been provided to us, we have parallelized the code using different methods, and later we have a comparison using different number of code to determine which is the best technology to achieve less computer time. Next, we will see the data provided by the project mentor. For the development of the project, we have presentation with 2 pieces of information. On the one hand, the test data that is a section of the final data, and on the other hand, the final data that is stored in an external service with Mongo. These data have a number of consumers to gather their energy consumption data. In this session, we will see a description of the script used. There are 6 ways to run the code provided by the mentor. In the first instance, we have the sequential version, the one provided by the teacher. Then we have a using for each loop. It's an improved sequential version. Finally, we have the first parallel version. This is called do_par. For use, this is needed the library do_par for each and parallel. Finally, on this slide, we will be able to see the other 3 parallel methods used for this project. In first instance, the make_apply method. It is one of the simple ways to parallelize the code and therefore one of the more commonly used. Then the parse_apply and parallel_apply method both use apply loop in parallel.
To accomplish the project, we will need the high-performance computer available at UL-FME. It is supplemented by more than 22,000 GPU cores available for fast linear algebra computations. And we connected to university's cluster, which is 48 cores, and cluster is connected to MongoDB, where our data stands with the API. So we are continuing with the experimental results. Firstly, we save the data, load the data, generate the model, and create the prediction. I will share the results with you. This is the final results of our experiments. You see in the first column, a sequential for loop is greater time than the for each do loop in the 3 of the cases. For your information, nmax is the sample number in the data set. So in the second column, when nmax is 10, there is no significant change due to 12 cores. But when we continue with the nmax is 100 and 1000, we see a same behavior, which is reducing in time by the increasing of the cores. And the reducing of the time due to 12 cores to 24 cores is greater when it is 24 cores to 48 cores. In the conclusions, we know that first step to take for this project is to know this data very well. After that, we need to know the technology we need to use, the parallelization methods. And we know that the number of cores are not always parallel with the higher processing speed. We know that cores for energy consumption measurement are better with 12 cores, but when it is for a large problem, it is better with the 48 cores. We know that with better technology, get the same results for all the methods. Thank you for your attention.